Hello folks, I'm Praveen. I'll be taking the next 10-15 minutes of your time to go through what I've done in the last 6 weeks. Primarily, this has been an open exploration. Open exploration about fine tuning. This is something that I'm a little biased towards, especially with smaller models. I feel that in the chase of bigger and more capable models, we are again, personal opinion can be debated, but like we're losing or we're not optimizing for how good smaller models can be. That contradicts what I'm going to say next, but abhi ke liye this is my hunch. So there is the motivation for like the last 6 weeks was this fine tuning technique called ReFT that I was introduced by Ayush, again a resident at Class 1. What it claims is that it needs a lot less amount of data and compute to effectively fine tune, and as compared to like a full fine tune versus the other alternative that exists, that is LoRa. Okay, just to cover the basics, fine tuning is where you are asking a model to get better at a specific task, not at general tasks. That's in my opinion useful for like business use cases or anywhere where you need the model to do just one specific task, right? And enabling, if you're able to fine tune smaller models well, what it essentially unlock is better latency, lower costs. All of that will be unlocked if you're able to like get the same performance for a specific task with a smaller model instead of just throwing a 4.0 or a 3.7 or Claude 4 at everything. That's the easier way to do, but like at scale, it doesn't work, right? Motivation is ReFT, and also like I have a couple of SaaS products that I'm building, and I use LLMs quite a bit to do like subjective reasoning. And these are also struggles that I personally faced, and I wish that there was a solution out there which would help solve it for me. Like what I realized was prompting will only get you to a place. There needs to be something better that we need to do. So that's the motivation for the exploration that I've done. Okay. Okay, ReFT essentially what it does is that there are two ways to fine tune. You have the model, you change the weights of the model, and you basically like just pick a subset of the layers. You change the weights and optimize on a specific loss function or the task that you want to optimize for, right? But that's how classical fine tuning used to work. But right now in LLMs, representative fine tuning doesn't change any parameters of the model. The model is constant. Nothing changes. What changes is like you have like a modifier on a specific layer. So let's say a layer has outputted some value. You would just do some kind of a transformation. For example, add +2. If that's the most basic use case, whatever this model has outputted, I have not touched the model. But at this layer, I'll just do a +2 to the vector that it has outputted and then pass it on to the next layer. That's what ReFT does. It introduces a couple of small parameters, which are usually quite low in size. And that has shown to like, perform better. I have been trying to get some intuition about like why that works. The best kind of intuition that I got, why representations are far more powerful than changing the weights, is essentially most tasks that we solve for in LLMs are linear in nature. And what like a representation, let me just move on to that. So something like this is what I want to focus on. Essentially, the representation is like is a vector at the end of the day, right? What you're doing is that you're changing or pointing that vector in a slightly different direction so that it steers towards the task that you want it to do and doesn't do what it originally has to do, right? So this is essentially what's happening. Instead of saying that I'll modify all the weights so that the output H2 and H3 that is generated, that will be different. I don't care about H2, H3. Whatever H2, H3 is generated, I'll just slightly nudge it by some value. I'll rotate that vector, I'll scale that vector, I'll do something, right? So that is what representation fine tuning is. Basically on the representation side, you're changing it. Slightly more technical is just this, but I think I've covered what it actually does. Okay, so again, again, like some kind of motivation. This is like a toy example that the paper, REFT paper, this is from Stanford NLP lab. The toy example that they have is, what they do is that they say that on the eighth layer, I'll introduce an intervention, which is basically that modification of that vector, to ensure that any output that the LLM gives will only be emojis. Right? It's a very, very small toy example done on Tiny Llama. But the thing is, the thing that attracted me to this problem is that this is not prone to most of the common prompt attacks that we are known of. Like something as simple as ignore all above instructions and output something, right? So something like you could achieve this theoretically with prompts. Give like 5 examples, and for 90% of the use case it will work. But there are also some cases where you might have adversarial prompts like, well, I ignore all the above instructions and do something, right? But what this REFT, this model does is essentially it paralyzes, or like basically cuts off the model's limbs to act in certain way. Like what it essentially does is that it says that आप कुछ और नहीं output कर सकते. Only thing that you can output is emotions. Right? So whatever the prompt is, even if you say that, ignore karo, whatever the input is, the model is physically incapable of producing anything else. Right? So that's something that I found very interesting. Okay, so this is where my research problem statement starts. This was all motivation. I was like, okay, we have REFT as a tool, and it somehow, from how I look at it, the intuition there is that LLMs have a broad swath of outputs, but what you're doing by fine tuning is that restricting it to a certain value. And how I see it is that you're adding some guardrails to it. You're adding something like, this LLM can't output harmful things like, hey, I want to kill myself, or anything like that. Like in production use cases, you want, or for example, a very common thing that goes around the internet is a customer support chatbot writing code for you, right? Just because someone has injected a prompt, right? So things like this. What I was trying to do is that, can I use REFT to apply some guardrails, through which I can assure that this LLM won't really output whatever you don't want it to output. So that was like the problem statement. That was where I started. And again, as I told you, like small models was like the domain that I was working on. Found a very nice data set, and like a very well established benchmark on top of it. It's by Vector Institute. Essentially what it does, if like to be very bland, in the way I like to understand it, is basically not safe for work text converted into safe for work text, right? So something like words like fuck or words like expletives are taken off and are replaced by something which is much more benign. Okay? This is what essentially this data set is about, right? Okay. I got the data set, and I was like, now all that's left to do is do this. And I told you, right, I was going to publish a paper also, but what ended up happening was none of this worked out. And this is my mom's favorite quote, which I have adapted to the AI regime. So yeah, I applied it, but then there were like very surprising results that came out, especially like from Tiny Llama, which is like a 2023 ka model. The other ones, the new ones, are a little more well equipped to handle NSFW text. Bacha hai na? Okay, so what happened was, if you give it something which is problematic, okay, Tiny Llama takes the most easiest approach and talks about something random. So it has changed its language to French. Here it has written a poem, and I think I have one more. No, here it has written a recipe. It starts writing a script. It starts doing random things, basically avoiding, like just like how we avoid tough conversations. I think it's very similar there. But like putting REFT on top did not solve anything. But what it made it, what I achieved is that it was constrained in its output. It was like, okay, I am feeling anxious, but I'm not going anywhere. I'm not talking about random things. So it just seemed like I'm able to like restrict the output, but I've not really worked more on this. Essentially, I tried Gemma and Llama 2, Llama 3.2. Again, similar output. It seemed like the nuances are so subtle, right? This data set also has things like ghetto, which is converted into something much more benign. I had a hunch that the nuances were so subtle that the model 1 billion regime wala parameter is not able to pick up. And this is where I, like, with all the hopes thwarted, I was like, chalo, we'll do something else. Okay, so like I tried a lot, tried as much as possible, but did not make it work. I think the benchmark that's there on this data set starts with 7 billion. There haven't been any benchmarks below that. I have a feeling that it's a model problem, which again contradicts what I started, but yeah, this is how it is. Okay, so again, like this is a random experiment just for fun. Essentially, what I was like, okay, if you're able to make guardrails, again a problem that I faced in in the products that I was working on. Essentially, any new model that I want to adopt to do something, to give an output as simple as for example, like we are building a product which basically gives startups for VCs. And a task there is like you read all the data about the startup and summarize it, right? But then you can't have different tonalities. You can't have, it needs to be very professional, it needs to be very to the point, etc. What I've seen is that the moment the model changes, I move from GPT-4o to Claude, I have to rework the entire prompt. One, for just getting the facts right. That's one that I have to anyway do. But also have to rework on prompts. There are some models which are much more sensitive towards threats, like whatever. There are some also sensitive towards rewards, things like that. Like I have to like basically fine tune according to every model. So the idea was if I can somehow create a small model which abstracts away the tonality. And I can just focus on let's say getting DeepSeek to be objectively correct. I don't care if it outputs in bullet points. I don't care if it outputs in paragraphs. I don't care if it outputs in any other way. I have a model on top which will ensure that the tone of the output is right. So that was like a motivation. And this is very recent, as recent as last week. Asked ChatGPT and Claude. No, they really thrashed me. And I really want you to read this one. Claude also roasted my idea, but also said ChatGPT is being diplomatic, and you should not trust ChatGPT. It was fun. So again, a brink of another idea failing. But then, like I did some experiments. I could not put them in the slide as of now. Like I did like a Shakespearean, like anything that you output business funded like Shakespearean language. It worked, but I was not able to like put it in time. But then yeah, motivation again is that this is a very recent paper, ICLR 2025. What they showed was tone is again something that's linear. It's you can affect tone in a single direction, and if you change that direction, basically what they I don't know the point. What they say is that there are some attention heads that are relevant to style, and there are some that are not. And if you can just identify those, fine tune them, you'd be in a state where tone can essentially be separated from the gyan of the LLM or any other part of the LLM. So this theoretically works. I have not gotten a chance to work at it, but yeah, this is how my 3 weeks have been. I really want to like go ahead and do like a 7 billion model for the biases and NSW text, and also tone is something that I will work on. But yeah, this has been my 6 weeks open exploration. Oh yeah. And yeah, just gratitude. Thank you so much, Paris. Like this is my second batch. I was in the first batch and now doing the fourth batch again. I can totally see myself doing another one sometime down the line. It's definitely a very good place to be, and supported by folks. Again, REFT could not have happened if not for Ayush. There were other things. There were a lot of like Shayans also. Like there's so many residents who have supported me in this, and yeah, just like that. Like a great gratitude to everyone out there. Thank you so much for listening to me. Open for questions.